In this problem, we have a military plane that flies horizontally at an altitude of 8,000 meters at a speed of 100 meters per second. So that means that that dimension right there is 8,000 meters, and it's flying at a speed of 100 meters per second. As measured along the ground, how far from the target must the plane be when it releases the target's provisions? Now, provisions are necessities. Basically, what we have here, you can see in the picture, we have a besieged city of GG. That means good guys. We have a besieged city of good guys. It's surrounded by BGs, which are bad guys. The good guys are trapped, and they're running out of provisions. And we aren't able to break the siege yet for some reason. So we're going to drop some provisions in there to keep them alive until we're able to come up with some other method to break through the line of BGs. And whenever you're talking BGs, it's all about staying alive. Whether you're a mother or whether you're a brother, staying alive. Staying alive. Feel the city breaking and everybody's shaking, and we're staying alive, staying alive. Ah, 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 staying alive. It's all about staying alive with BGs. And so what we want is this distance right here. As measured along the ground, how far from the target must the plane be when it releases the target's provisions? And isn't that a dx right there? What's this 100 meters per second? That's a Vx. And what's this 8,000? That looks to me like a dy. That's a displacement in the y direction. You see, if you open the bomb hatches too soon, then the provisions will land and these BGs will get it. And if you open the bomb hatches too late, then the provisions will overshoot the city and these BGs will get it. And when we're talking provisions, we're just talking essentials. We're talking things like Spam, Cheese Whiz, and Wonder Bread. Fresh water, don't need it. Blankets, don't need it. Just the essentials, Spam, Cheese Whiz, and Wonder Bread. And if you've ever seen bad guys hopped up on Spam, Cheese Whiz, and Wonder Bread, that's the worst thing. It would be better to not even give these good guys anything than for our Spam, Cheese Whiz, and Wonder Bread to fall into the hands of the BGs. So it's very important that we open the bomb hatches at the right time so that the Spam, Cheese Whiz, and Wonder Bread, boom, right into the city like that. We need dx. Let's look at our Venn diagram here. In order to find dx, we need to know two things, Vx and time. Vx we know, it's 100 meters per second, but time we don't. So the left side of this diagram, we're stuck right now. But what we need to do then is we need to use the right side to calculate time. Then we can use the left side to find out what dx is. We know what dy is. We've said that that's going to be about 8,000. The acceleration due to gravity, we can write that down. Since this plane is flying horizontally, we know that Vy initial is equal to 0. And using this equation right here, we should be able to calculate the time. And once we have the time, we're going to use this equation, which basically is an equation you learned in what? 4th grade? Distance equals rate times time. Basically what that is. I'm going to say that downward is positive. And if downward is positive, then that means that this 8,000 meters is a positive number. It means that my acceleration in the y direction is a positive number because the acceleration is due to gravity, which points in the direction that I've shown right there in that bubble. And of course, Vy initial, because this is a horizontally launch projectile, you can see I've underlined the word horizontally, AY initial is equal to 0. Let's do it. Dy is equal to Vy initial times time plus 1/2 AY times squared. Vy initial is equal to 0. We've done this several times now. We've solved this for time. Multiply both sides by 2. Divide both sides by AY. Take the square root. 2 times 8,000 divided by 9.81. Square root that whole thing, and that comes out to be 40.4 seconds. That's how long these provisions are going to be in the air. And we said, once we found the time, right here where I'm pointing in the middle of the screen, we can now use distance equals rate times time. We know the rate is 100 meters per second, right there where I'm pointing, so we can find dx. Dx equals Vx times time, 100 meters per second to the right. Every second, 100 meters to the right for each of 40.4 seconds. We need to be just over 4 kilometers away when we drop our provisions. The next question is, how fast are the provisions moving when they land? When those provisions land, hopefully you will remember the picture on the previous slide, they're going to be moving kind of like that. They're not going to be moving horizontally. They're not going to be moving straight down. They're going to be moving at an angle. And that is the vector that we want right there. Now, to find that vector, what we need to do is we need to know the x component of that vector, Vx, and we need to know the y component of that vector. Vx we know, that's 100. Remember that Vx stays the same for the entire time that the Spam, Cheese Whiz, and Wonder Bread remain in the air. To find the speed with which they land, we therefore first need to find Vy final. So let's go to our equations here. What equations have Vy final? Not this one. That would be a bad choice to use this time. How about any of these others? Any of the others would pretty much be okay to use. I'm going to go ahead and use that one because we know AY. We know the time, it was 40.4 seconds, we just found it, and Vy initial was 0. Therefore, we should be able to calculate Vy final. Let's do that. AY is equal to Vy final minus Vy initial divided by time. Vy initial is 0. So that means that Vy final is simply AY times t. So if we write this equation out, cross off Vy initial because it equals 0, which means that Vy final is equal to AY times time. AY is 9.81 meters per second squared multiplied by the time. That gives us 396 meters per second. 396 meters per second. And we learned a long time ago that if we wanted to find the magnitude of a vector that had 2 components, you use the Pythagorean theorem. So let's do that. The magnitude of V is going to be 100 squared plus 396 squared, square rooted. And when I do that, that comes out to be 408 meters per second. We won't go through it here, but if we wanted to, you could tell me, couldn't you, based on the previous things that we've done in this class, you could tell me the angle below horizontal. that those provisions hit at. And if you calculated that, again, I'm not going to do it on this video, it would come out to be 75.8 degrees below horizontal. However, because this question just asks how fast, the only bit of this that you really need is the 408. If I had said, what's the velocity of the provisions when they land, then you would have to have this entire answer here.